Hey guys, so let's do another video on absolute value, but this time we're going to do inequalities. So the inequalities, of course, will be in place of wherever the equal sign was. So let's get started. Alright, in this case, what this is should be review. When we had the absolute value of x greater than or equal to 7, that means 7 could be a possible answer because it's equal to it, and it would of course be greater than 7, so we would fill in, and this is equals, so we would fill in a solid circle at 7, and then we would shade greater than that. And the other solution, of course, could be negative 7. So we're solving this like before. Alright, so this could be positive or this can be negative. So negative 7 would be here, and again that would also be filled in. Now what's going to happen here, however, is that the sign will be flipped. So now why will the sign be flipped? So let's think about the positive way. Let's say we plug in 8, right? We get 8, and just to make sure we're shading in the right way, let's plug in 8. Absolute value of 8 is definitely greater than 7. Alright, now if I plug in negative 6, I would drop the negative, right? Negative 6, and it become positive 6 greater than or equal to 7. That is wrong, okay? So that's why the sign is going to have to flip here, because we really want these values. So if we would just to trial it, plug in negative 8. So negative 8 would drop the negative, and yes, 8 is greater than or equal to 7. So it will flip when you do that negative answer, and it'll go in the opposite direction. So this is what it would look like, and of course you could check this in Desmos, and I have a different one in there. What was it? 7. So the value of x is greater than. Now to do equals, all you have to do is push the equal sign on your keyboard. It's the fastest way to do it. On your keyboard, just push equals after your inequality, and it automatically adds that in for you, which is awesome. So here's what it will look like. Okay, your solutions are here. So it's positive 7, and here negative 7, and then they're shaded this way, and the lines are solid, meaning it's the equal bar. If we take out the equal bar, then they go to dashed. But of course in this case we want solid. So that's how it looks like on Desmos versus on just a plain old number line like we have here. We can write this, remember, in interval notation. So we start from left to right. From the left we come to infinity shading. So negative, it's actually negative infinity, comma, negative 7. It can be equal to negative 7, so we put a bracket. And then we unite that with positive 7. So we have nothing, so we don't put anything until we have 7. And then 7 to positive infinity. Alright, in the case of less than or equal to, very similar, in fact exactly the same. So your regular answer will be 4, and x is less than or equal to 4. So we're shading this way. Now I'm not going to shade completely. My other answer is greater than, so x will be less than 4, and then I flip the sign, x is greater than or equal to my negative 4, negative answer. So that would be a solid dot here, but x is greater. So greater meaning this way. So they end up coming into each other and having one section on the graph instead of two sections on the graph. Checking this out in the calculator. Oh. Well. Push the wrong button. There we go. Alright, absolute value of x less than or equal to 4, and again we get those shaded, that shaded area is in the center. So, how does that look in interval notation? Well, it's a little bit less writing. And this indicates you have two sections shaded. This indicates, well, and then you only need one of them if you have one section shaded. So the first thing we come to is negative 4. So bracket negative 4. and then that continues to positive 4, and then both of those are equals, so we use brackets. All right, not too bad, hopefully. Okay, so what does this mean about absolute value inequalities? Absolute value inequalities are compound inequalities so compound meaning more than one part. Okay. There you go. And the steps to solve. Going to be kind of similar. Isolate the absolute value part of the expression. Create your two cases. And they're reminding you to keep and switch the signs. Solve both of the inequalities and then graph your solutions. We can, for the most part, do these in the calculator because that's just how you're going to do it on the SOL test or any of the tests. So, but we will go ahead. Let's do one by hand. So to show you, absolute value is already isolated. So my two cases would be x plus 6 is greater than 7. So I want to leave it the same if that's a positive answer. And then when I do my negative case, x plus 6 equals negative 7 instead of equals, we have an inequality. And what that indicates is that we will have to flip it because of the negative. So keep this one, and on this one, switch the sign and make it negative. Okay? Then you solve for both. So these are my two equations. So open circle at 1 and open circle at negative 13. And x is greater than 1 and x is less than negative 13. So this is one that ends up having two sections. Interval notation, negative infinity to negative 13. This time a parenthesis, since it's not equal. Union with 1 to positive infinity. Okay? Alright, and then of course you will have some where you have to isolate the absolute value. Let's do one of those. Maybe which one looks a little complicated? Let's jump down to number 9. That one looks complicated, you think? Okay. So the absolute value, we got to get that by itself. We got to minus the 7 over. Alright, divide by 6. Trying to make those absolute values a little bit distinctive, so a little bit higher than the rest of your numbers. That would be helpful. Alright, we've got this case, so didn't divide by a negative, so we don't have to switch anything, but and it's not a negative here. So the absolute value of something has to be greater than 5. So I want negative 5n to be greater than 5, but I also want negative 5n to be less than negative 5. Let's see what happens. So, isolate this, divide by negative 5. N is greater than negative 1. Alright. Oh, wait, we divided by a negative. So, since we divided by a negative, that should be n is less than negative 1. Alright, over here, divide by negative 5, divide by negative 5, and again we flip the sign, so n is greater than positive 1. Alright, now, let's see what this gives us in the calculator, just to be sure. Since we haven't done one of these yet. The absolute value of 6 and then negative 5x plus 7 greater than, oh, nice message. Sometimes you just start humming a Christmas song. Let's see what Desmos tells us. It tells us the same thing, -1, less than -1, greater than 1. Let's just make sure our signs are right on that. Yeah, less than the -1 and greater than the +1. Alright. Looks like we're good to go on that. Sorry about that. I failed to turn my phone on silent before I did this video, but that's okay. You'll probably do the same thing while you're watching this video. Alright. Interval notation. Negative infinity to -1, and those are open. Union with 1 to positive infinity. Alright! So, what do you think about that? Not too bad, hopefully? Desmos will be your friend, so definitely check everything in Desmos and see how it goes. Alright, let me see if I see anything else that's that I think you might have trouble with. Watch out here just to make sure that this negative goes away when you move this stuff over. Just watch out for that because you don't want to set an absolute value with the negative. Same thing here. So, okay. There's not really much more complicated things to show you, so go ahead and pause the video and then press play when you are ready to see any of the solutions. I'll have all of them here for you, but you don't have to do all of them if you feel good about it, so yeah. Booyah! So, here are the answers. Here's number 2. If you need to pause the video at any time, if I'm going too fast, then pause it. Here's number 3 and 4. Here's number 5 and 6. Here's number 7 and 8. Here's number 10. And here's numbers 11 and 12. If you need to see any additional work, like by hand, just come see me in class or in office hours. Alright, that's it. Nice and short and sweet. Oh yeah. See you next time.